Hey mathematicians, today our lesson is over multi-digit multiplication using standard algorithm. Our TEK is 4.4D using strategies and algorithms, including the standard algorithm, to multiply up to a 4-digit number by a 1-digit number and to multiply a 2-digit number by a 2-digit number. Let's go ahead and read our learning goal together. Today I am learning how to multiply multi-digit numbers so I can estimate and solve real-world problems. I'll know I have it when I can define and identify factor and product. I can explain that multiplication is the same as repeated addition. I can choose a strategy to use to fluently multiply 4 by 1 digit and 2 by 2 digit multiplication problems. Let's look at some real-world connections. Why do we need to know how to multiply large numbers? We know multiplication is a shortcut for counting equal groups. This skill is important for many real-life situations. Multiplication comes in handy when planning a trip. For example, you want to travel cross-country to see the Grand Canyon. Knowing how to multiply will help you calculate gas costs and mileage. Without it, you might find yourself stranded. Summer's here and you want to have a water balloon fight with your friends. Multiplication can help you find out how many water balloons to buy if you want everyone to have the same amount. It is only fair. All right, let's quickly review our vocabulary before we get started on our mini lesson. Multiplication is a shortcut for repeated addition using an algorithm. Factor is a number that is multiplied. A product is the answer when two factors are multiplied together. Partial products are a way to multiply in which the ones, tens, hundreds are multiplied separately and then the products are added back together. An expression is a mathematical phrase without an equal sign. An equation is a number sentence that shows two quantities are equal. So remember, equation has an equal sign. Equation equal. All right, let's go ahead and get started in our mini lesson. But first, I want to quickly review multiplication. Multiplication is just repeated addition. It gives us a shortcut called an algorithm. That's a fancy way to say strategy. Let's look at an example. Bella was setting the table. There are 8 people eating dinner and each person gets 3 utensils, a fork, a knife, and a spoon. How many utensils are on the table? So we could use repeated addition. We could add this 3. We could add that over and over and over 8 times to get a product of 24. We could use equal groups. We could have 8 groups and put 3 utensils in each group. We could use an array where we have 8 columns and 3 rows. Or we could use a number line counting by 3s 8 times. Whatever we use, we're going to get a product of 24. But what happens is when our numbers get larger, we need other strategies. So just like when you learn to read, you need to know letters and sounds, it helps to know your basic multiplication facts from a times table in order to be a fluent mathematician. So we're going to be referencing this times table quite a lot, as well as practicing our multiplication facts so we can become fluent. I'm going to link this multiplication chants and songs for you guys as well. So today we're going to learn how to do standard algorithm, which is just a way of doing multiplication by using partial products. So the example we're going to use today is a video game company sent 3 coupons to 2,345 random people. How many coupons did the company send in all? So we know we're looking for a total. So we could add 2,345. We could add that 3 times, but using multiplication tends to be quicker. So to start our standard algorithm, we're going to multiply the ones place times the ones place. So we're going to multiply this 5 times this 3. Notice that I have my larger number on top, and then we're going to record the product of our ones place times our ones place below. So 5 times 3 gives me a product of 15. So I'm going to drop my 5, carry my 1 up to the tens place to regroup. Then I'm going to multiply the ones place on the bottom by the tens place. So I'm multiplying this single digit. I'm multiplying it by every place in this 4-digit number. So I'm going to multiply the ones place by the tens place. So 3 times 4 is 12. And I'm going to add any tens that were regrouped. So this 1 plus 12 gives me a total of 13. So I'm going to drop that 3, and I have to carry the 1 to the hundreds place. Next, I'm going to multiply the ones place times the hundreds place. So then I'm going to multiply 3 times 3 to get a product of 9, and I'm going to add in this 1 that I regrouped. So 9 plus 1 gives me a total of 10. So I'm going to drop my 0, carry my 1 to the thousands place. Next, I'm going to multiply the ones place by the thousands place. So 3 times 2 gives me 6. I'm going to add this 1 that was regrouped. 6 plus 1 is 7. And now I can record my product in the thousands place below. So now that I have nothing else to multiply, I've gone all the way through the thousands place. I have nothing in the 10,000s place, so I'm done. So my total product is 7,035. So I'm going to link this video for you guys. It's a video showing you how to do standard algorithm multiplication using blank lined paper. Let's look at an example of a 2-digit by a 2-digit number. The U.S. soccer team was calculating the number of minutes they had practiced to prepare for their big game. If they practiced for 75 minutes a day for 45 days, how many minutes did they practice in all? So because we're looking for a total, we're going to be multiplying, right? I need 75 minutes for 45 groups, 45 days. So we're going to start off by multiplying our ones place by our ones place. So notice I have my 75 up top, my 45 on bottom. This is probably one of the few times where it really doesn't matter if the bigger number is on top or on bottom, but it's a great habit to get in, putting that larger number on top. So we're going to start by multiplying our ones place by our ones place. So 5 times 5 is 25. We're going to drop the 5, carry the 2 to that tens place. Next, we're going to multiply that same 5 from 45 in the ones place in the tens place on the number on top. So 7 times 5 is 35, plus this 2 that we regrouped gives me a total of 37. So I'm going to drop the 7, carry the 3. Now notice that because I have nothing left to multiply in this hundreds place, there's nothing for this 3 to be added to. So I'm going to go ahead and drop that 3 down into the hundreds place. So we're going to drop a 0. We're going to drop down to this next line. This is our second partial product. And I'm going to write a 0 in the ones place. This is your placeholder because you're moving on to the tens place in the problem. So I'm done with this 5 in the ones place. I'm now going to move on to the 4 in the tens place. So when moving to the tens place, we're now multiplying by a multiple of 10, which we know will end in a 0. For this example, we first multiplied in the ones place. We multiplied 75 times 5. Now we are multiplying in the tens place, so we're multiplying 75 times 40. Since we know that when we multiply by 0, we get 0, we know that if we multiply 75 times 0, it will be 0. So we can add this placeholder 0 since we understand there will be no units when multiplying by 0. Next, we're going to multiply the tens place on the bottom, so this 4, by the ones place. So we're going to regroup any tens that we have. So 4 times 5 is going to give me a total of 20. So I'm going to drop this 0, carry my 2 to the hundreds place. Then I'm going to multiply the tens place on the bottom by the tens place on top and add any tens that were regrouped. So this 4 times 7 gives me 28, plus this 2 that was regrouped should give me a total of 30. I would need to carry this 3 to the thousands place, but because there's nothing there, I'm going to go ahead and drop it down in my thousands place. And lastly, we're going to add our two partial products together. 5 plus 0 gives me 5. 7 plus 0 is 7. 3 plus 0 is 3. 3 plus nothing is 3, for a total product of 3,375. So I'm going to link this video for you too. This is a 2-digit by 2-digit standard algorithm multiplication problem using your blank lined paper. All right, let's do a check for understanding. Why do we drop a placeholder 0 in standard algorithm? Go ahead and pause the video if you need some time to formulate your answer. When multiplying a number by 10 always gives us an answer that ends in 0. When we begin to multiply in the tens place, we know there will be no units in the answer and can simply use a placeholder 0. All right, guys, I will see you in just a second.